In this video, I will show you how to do problem number 7. And problem number 7 is to take this parent function and perform the following transformations. I see 3 transformations here. There is a reflection over the x-axis, a translation 2 units to the right, and 1 unit down. So that's what we're going to do. Let's take it one piece at a time. Let's start with this function over here, x plus 3 squared. That's what this function is over here. We're going to do the key values, which are here and here. All right, so we will do the transformation using these 4 values. Okay, let me make a little chart, which I think will make it easy for us. Okay, so we will do x and y. So this first point is the point -2, comma 1. So I have -2, comma 1. And then we have -3, 0. Great. And then we have -4, 1. Awesome. And finally, we have key point -5, 4. Okay. Now we're going to take these key points and we need to do this transformation. Okay, in fact, I think I'll recopy that nearby. So we have negative f of x minus 2 plus 1. Is that what it was? Yes. Okay, so let's start with what we have to do to the y value. All right, how will the y value change? Anything happening outside the function will happen to the y value. So this and this, these are the things that will affect the y value. So that's why you can find the y value by doing negative y plus 1. I did the negative and the plus 1 to the y. So the opposite of this is -1. Plus 1 is 0. Opposite of 0 is 0. Plus 1 is 1. I just got 1 comma 0 a second ago. The opposite of 4 is -4. Plus 1 is -3. All right, so these are my new y values. Now let's talk about the new x values. The new x values are going to come from what's going on inside the function. Please remember that a -2 right here is actually a shift to the right 2. That's why I will find my new x values by doing x plus 2. So -2 plus 2 would be 0. -3 plus 2 would be -1. -4 plus 2 is -2. And -5 plus 2 is -3. So these are the new x and y coordinates. So all I have to do is plot these red points, and that will be the new function. So let me just clean this up a little. All right, so remember we started from this point right here. That point is going to become 0, comma 0. All right, so you know what? Let me erase all of this real quick. Just clean up the graph. Make room for the magic that we're about to do. Okay, so 0, comma 0 is right here. And then we have -1, comma 1, -1, 1. And then we have -2, 0. Which would be right here, and -3, -3, which would be right here. Okay, so that means what we have is we have this going on like this. All right, something like that. So this little curve over here became this curve right here. All right, next let's transform this part of the graph right here. All right, let's look at the key points. This is a key point, this is going to be a key point, and this will be a key point. Those 3 points are really enough to, because we have straight lines, that will give us everything we need to draw this portion of the graph. So let's get our table of values going once again, but this will only be a table of 3. So x and y. Our first point is -2, -4. And then 0, 0. And then the point 3, comma, -6. 3, -6. Okay, remember we are doing the same transformations that we were doing a moment ago. The yellow transformations are happening to the y values, all right? Anything outside the function is happening to the y values. So once again, we're just doing opposite of y plus 1. All right, so opposite of 4 is positive 4, plus 1 is 5. All right, opposite of 0 is 0, plus 1 is 1. Opposite of -6 is positive 6, plus 1 is 7. And once again, for the x values, we are going to do x plus 2 because this is to the right by 2. So -2 plus 2 is going to be 0. And 0 plus 2 is 2. And 3 plus 2 is 5. So these will be the new points for this portion of the graph. All right, let's graph them and see what we've got. We'll do this one in purple. So 0, 5. Remember, this is what happened to this open circle right here. So 0, 5 is going to be an open circle. All right, next we're going to see what happened to this corner. So that becomes the point 2, comma 1. So that's going to be right here. And then finally, what happens to this closed circle? It becomes 5, comma 7. All right, so 5, comma 7 is right here. So now all we have to do is connect these dots, and that'll be it. I want this in purple, so I'm just forcing it to be purple. Okay, I guess I have to do it again. All right, so there you go. This purple is what happened to the absolute value portion, this v. All right, now let's see what happens to the final part over here, the cubic part of the function. All right, so key points. And we'll do this one in green. So here's a key point right here. And here will be another key point. This will be another key point. And you know what? It looks like it hits right here at 8, which makes sense because 2 to the third power is 8. So these 4 points are going to be key values. So let's make our little table off to the right this time. All right, so x and y. So this open circle is at 3, comma, -1. And then this inflection point is at 4, comma, 0. And the next point is at 5, comma, 1. And the final point is at 6, comma, 8. All right. So again, let's start with the transformation of the y values. And that's going to be this and this. Anything outside the function is happening to the y values. So that's why we're doing opposite of y plus 1. So opposite of this is positive 1, plus 1 is 2. Opposite of this is 0, plus 1 is 1. Opposite of this is -1, plus 1 is 0. Opposite of this is -8, plus 1 is -7. Now let's see what happens to the x values. The x values are being transformed by what's happening inside the function. And this is a shift right to, which is why I'm doing x plus 2. So 3 plus 2 is 5, 4 plus 2 is 6, 5 plus 2 is 7, and 6 plus 2 is 8. That gives us our brand new x and y values. So we can forget about the old ones, and we're going to use these green ones. All right, I think I'll zoom out a little tiny bit. And let's see what's going on. So remember that the first point is the open circle. All right, just keep track of sort of where we're starting. So what happened to this open circle? It went to 5, comma, 2. All right, so 5, comma, 2 is right here. So this will be the open circle. Next, what happened to this point? It becomes 6, comma, 1. All right, the next point is 7, comma, 0, which is right here. And then finally, we have 8, comma, -7. So that's going to be right here. Now, remember what this path does. If I only had these 3 dots and no context, you might think it just went straight through these 3 dots like this. And I mean, I guess it has to come down here eventually. But it does not just go straight through these points. It curves one way, and then it curves the other way through those points. Okay, now this is upside down. So this was a downward facing curve. So this will become this upward facing curve like this. All right, now this next little part was concave up. It was curving upwards. So when I draw it right now, I'm going to make sure that I curve it down like that. All right, so don't just draw a line straight through. Do an inflection point. Do a curve and one way and then curve the other way. It's an inflection point. All right, and now it's going to come on down and pass through this guy. Now I'm not great at drawing this, and I feel like I would do better just plain cheat, because this is not really supposed to be a straight line, but I feel like a straight line is close enough. All right, I feel like that looks way better than whatever I would have drawn. So let's go with it. All right, so really we are done. I'm just going to erase these blue distracting points, and let's zoom out and take a look and see what we had. All right, so we had the original function, which was here in red. And then I did the transformations to each part. And you see we have this sort of fuchsia color and the purple and the green. That's what the function looks like after the transformations.